All right, today's lesson is 51, negative exponents. What?
Negative exponents.
Let's try that one more time. Negative exponents. What?
Negative exponents.
Thank you. Scientific notation for small numbers. What?
Scientific notation for small numbers.
Very good. Today we're going to use the law of exponents with negative exponents, and it'll also apply to scientific notation. So recall what we've done in the past when we had x to the fifth divided by x to the third, we get x to the second, because we knew you take the exponents and you subtract them. 5 minus 3 is 2. The long way is to expand the top, expand the denominator, and then cross cancel to get 1, 1, 1 times x, which would be x squared. So if I were to do this method, 5 minus 3, I'd get the same thing, x squared. Well, what if I took this fraction where the denominator is bigger? It has a larger exponent. We've never seen those before. So let's find out what happens. If I expand it, I'm going to get x, x, x on the top. On the bottom, I get x, 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 x. I cross cancel. And I'm left with, on the top, there's nothing there, but I knew that all these turned into 1, so I really have a 1 over x times x, which is x squared. So wait, I thought the law of exponents said to subtract these. 3 minus 5. Well, that would give me, if I write it on this side, that would give me x to the 3 minus 5, which is negative 2. So wait, you're saying this and this are the same?
Mm-hmm.
Yeah. Yes, I am. Today's new law of exponents for negative powers says that if x has a negative exponent, you are going to write it in the denominator with a positive exponent. So you're going to write now in your notes, write down the following law. X to the negative n equals 1 over x to the positive n. In other words, if your exponent's negative, you rewrite it in the denominator. Where do we write it? Get ready?
Denominator.
Denominator. And the sign of the exponent changes. You just take the opposite of the sign. Okay? So in this case, we will go from a negative n to a positive n. What sign does it change to? Get ready?
Negative.
Positive, or negative to positive, or the opposite. Okay, so let's look at, as soon as you're looking up, I'll know your notes are ready. Okay, good. You guys are up fast. Okay, let's look at powers of 10 and kind of understand how these negative exponents really work. We know that 10 squared is 10 times 10, or 100. We know that 10 to the 1 is 10. We know that 10 to the 0 is 1. We know that now with our new law, this says if the exponent is negative, we write it in the denominator. Where do we write it? Get ready?
Denominator.
Denominator. And then the exponent changes sign. So really this is 1/10. So wait, we got 100, 10, 1, 1/10. And look, I'm stepping 2, 1, 0, negative 1, negative 2. This one's going to be 1 over 10 to the, what does my exponent become? Get ready?
Second.
The second power, or squared, which is 1 over 100. What happened as I'm stepping down in integers with my powers, what's happening to my value of my expression? Gauge.
Adding a 0 on the denominator.
On the denominator, you bet. So from 1/10 to 100th, it's adding that 0, or a factor of 10, right? Is this 10 times smaller? 10 times smaller? 10 times smaller? 10 times smaller? Yes. So it follows the negative exponent is going to actually, you're going to find out it's going to make it smaller and smaller and smaller. That's why we can use it for scientific numbers, and we'll get to that in a second. So we're going to simplify using our new laws. We're going to simplify all of these quickly. All right, 3 to the negative 3. Where do I write the 3? Where does it go? Numerator or denominator? Get ready?
Denominator.
Denominator. So the 3 goes in the denominator, and then the sign of the exponent turns positive. What sign does it change to? Get ready?
Positive.
So 3 cubed. But I'm not done yet because it's not in its most simplest form. So I'm going to write 1 over 3 cubed, which is 3 times 3 times 3. Think. Get ready?
27.
27, very good. So that's the simplest form, done. How about this one? 2 cubed, it doesn't have anything negative in it, so I'm not going to do any new weird stuff. I'm just going to leave it alone. But this one has that negative in it, so I'm going to do something to that one. So let's rewrite the first, 2 cubed. Oops, times. This one says if it's negative, I write the 2 in the, get ready?
Denominator.
Denominator. Some of you knew where I was going with that. So the 2 goes in the denominator, 1 in the numerator. My sign becomes positive. And then look, I've got 2 cubed times 1 over 2 cubed. It's like this is the same as in the numerator as it is in the denominator. So it all cancels and I get 1. Think about that. Okay, give me a nod if it makes sense. All right, okay, good. Kaylee.
Couldn't you also just take the exponents and 3 plus minus 3 equals 0, so 4 to the 0 is just 1?
We had a law we've learned previously that says if the bases are the same and you're multiplying, add the exponents. So keep the base the same. 3 plus negative 3 really gives us 2 to the 0 power, which is 1. So can you use either law? Yes. You can use the law of negative exponents or just the regular law of exponents. Let's try Kaylee's way in this one. The bases are the same. Let's keep the base the same. 3 plus negative 5 would give us 4 to the, what's 3 plus negative 5, think? Lexi?
Negative 2.
Negative 2, very good. Which, is that in simplest form? No. So how should I rewrite 4 to the negative 2 using my new law, Gage?
116.
Oh, you are good. You did that step all in your mind. So 4 to the positive 2, which is 1 over 16, simplest form. Boom. Excellent. 5 to the third, negative third, your turn. Solve this on your paper. Write this in simplest form. Put your pencil up when you've got it. 5 to the negative 2, use your negative law, or law of negative exponents. All right, let me call on, how about Sophie? What did you get, Sophie?
I got 1 over 125.
1 over 125. Raise your hand if you got 1 over 125. Okay, almost everybody. So very good. Let's check it real quick. We write it in the denominator. We change the sign. Whatever it is, we just change it. So we're going to do positive. And you know the common mistakes? I've seen a 75. I even saw 210 earlier today. This just means 5 times 5 times 5. So 5 times 5 is 25. 25 times 5, I think 5 quarters, $1.25. There's your $1.25. Okay. Negative 2 thirds. I added this one in there because I didn't want you to get confused that negative is just like the old stuff. It's not in the exponent. So this still just means negative 2 times negative 2 times negative 2. Don't let that 2 have anything to do with the denominators. It's just the old way. And then that would give you your negative 8. All right, multiple choice. Which of the following does not equal 10 to the negative 3? Now let's remember, let's just imagine, okay, we're going to go in the denominator. We're going to cube that 10. Which one is not equal to? We're going to take a vote. You have 5 more seconds to think in your mind. All right, if you think it's A, raise your hand. B, C, or D? D is correct. All right. I know if you're a test taker, you're thinking, well, this is the one that looks weirder than the rest, but this one is really equal to this one. Because you would take your 1 and you would move your decimal over 3 times. 1, 2, 3. There's your 3 0. There are 2 zeros right there. And this, we learned from earlier, that's 10 with the 3 being positive. So this is the only one. Don't look that negative. It's not, it has nothing to do with that negative. So this is the one to look for. It's not right. Take it. Okay, let's skip those 2. All right, so now we're going to shift into variables with a mixture of positives and negatives, and we want to rewrite these in simple form. This is a mess. So we want to clean it up in the most condensed, simple way possible. Step 1, write the given problem. What is our step 1? Get ready?
Write the given problem.
Write the given problem. The next step, circle the negative parts. Circle the negative parts. What are we circling, class? Get ready?
The negative parts.
The negative parts. And I do that so you can make a fraction. The ones that you've circled go in the denominator. Where do they go? Get ready?
Denominator.
Good, in the denominator. So I'm going to, right off the bat, write my x to the sign changes. I'm going to write my y to the positive 2, the sign changes. Now everything else on top, it didn't move. If I didn't circle them, they're already positive. I don't have to move them anywhere. So I'm going to write the 2, the y, the x squared, and the z. They don't go anywhere. Now my next step is to simplify. I'm going to cross cancel anything, and some of you can cross cancel by skipping this step. You can see, oh, I've got 1 on the bottom and 2 on the top, so this takes 1 away. But for right now, we're going to expand the top. 2y, x, z on the bottom. X, y, y. Now, cross cancel anything that equals 1. X over x equals 1. Y over y equals 1. I'm left with 2x, z all over just a y. Oh, that's much more simple. And there's no negatives. So if the question says, rewrite this expression in simplest form with only positive exponents, well, that's got all positive exponents. They're all 1s, but they're all positive. Okay, your turn. Copy this expression on your paper. That's our first step. Write down the given problem. Second step, circle the negative parts. What are we going to circle, class? Get ready?
Negative parts.
Negative parts. After you've circled your negative parts, you're going to rewrite it as a fraction with the negative parts in the denominator. And your exponents change sign. All right, a minute to work. Okay, let's check it. How about, let's see, Liesel, I haven't called on you yet today. Let's circle these because we already talked about that. Okay, what did you write first, Liesel?
So you load the line in the denominator.
That thingy, okay, on the bottom.
I put y to the third.
Oh, you're jumping one more step, but I see where you're going. Start out with just your positive 2, okay?
X to the third.
Yep.
And then y to the first.
Y to the 1. You were doing the next step. Then the top goes,
And then you would add them together. And yeah, and then the top goes y and x over.
Y and X, okay? What would my next step be? Hannah.
So on the bottom, you do y to the third,
Okay.
and then x to the third, and on the top would be y x.
Okay.
And then you would write 3 y's and 3 x's on the bottom.
So Y, 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 X, X, X.
And then you would cross out one of the y's and one of the x's. And then you have 1 on the top and y squared times x.
Excellent. I like that on the fly she knew, and we could have written Y, Y, X, X on the next step, but she just knew, oh, it would be simpler to say Y squared, X squared, and that's our final answer. Raise your hand if you had 1 over X squared, Y squared. Awesome. You did very good. You're listening so good today. Thank you. Okay, we're now shifting gears. We're going to talk about scientific notation. How does our law of negative exponents apply to scientific notation? We just barely did scientific notation last week. So think, isn't this a small number? Didn't we say earlier that that's equal to 1 over 1,000? That's pretty small, 0.001. So if I'm going to times a number by 1 over 1,000, I'm going to be making that number very small. That's how my mind remembers, negative exponents make numbers smaller, meaning I have to move that decimal to make it in standard form to the left, because that makes a smaller number. How many times am I going to move it? 3 times. 1, 2, 3. Draw my new point, fill it in with zeros, and then rewrite it so you don't have any swoopies to look at. So see how the negative exponent, I move my decimal to the left. Where do I move it for a negative exponent? Get ready?
The
left. The left. Very good. Let's do one more. This says -2, so I move it to the left. What direction? Get ready?
Left.
Left. 2 places. 1, 2. Try my new one. Fill it in with 0. Rewrite my number without swoopies. There's standard form. Now let's go in the reverse direction. If I start with a really tiny number, and I want to write it in scientific form, I know, oh, hey, this is going to be one of those negative exponent ones because it's a really, really small number. So let's count over till I have 1 digit to the left. 1, 2, 3, 4, 5, 6 places. 7.03 times 10 to the 6. But wait a minute, it was a small number, and we had to go left to get to there. We went right to go back to scientific. So my exponent is negative. Okay, just think, if you're moving to the left to make a really small number, you're gonna have a negative exponent. Give me a nod if you're okay. Makes sense? Mostly. Okay, you guys need to try a few practice problems and then you will get the hang of it. 350. Take a 20-second stand-up break.